Good morning. Last class we discussed about the intramodal dispersion. In that we discussed about material dispersion and waveguide dispersion. Now we want to discuss about okay. Last class we discussed about the material dispersion and waveguide dispersion. Now we want to discuss about the already we discussed the intermodal dispersion and intramodal dispersion. So in intramodal dispersion there is a variations in the uh, refractive index of the core or variations in the refractive index of the velocities of the different velocities of the group velocities, okay, of the fibers, okay. So based on that, the intramodal dispersion will be obtained. Coming to the intermodal dispersion, last class we discussed intramodal multimode step. Discuss the two different signals will be taken, and one signal will be maximum time period and second signal will be minimum time period. Based on the difference between the fastest ray and the slowest ray, that is T maximum minus T minimum, then we can obtain the some L by 4 square root of 3 N1 C into numerical aperture square. Last class we discussed so far this. Okay. Now we want to discuss the discussion in multi-mode index fiber. Last class we discussed the index fiber. Okay. Multi-mode step fiber. So there we consider only two ways. One is fastest ray and second one is the slow. The gradient index fiber means then there is a number of modes that will be propagated at a time. That will be propagated into the at a time. So the intermodal dispersion in multimode fibers is minimized with use of gradient index fibers. With the use of gradient index fibers. So the bandwidth is improved compared to the multimode step index fibers. Bandwidth అనేది కంపేర్ టు స్టెప్ ఇండెక్స్ ఫైబర్ గ్రేడియంట్ ఇండెక్స్ ఫైబర్ లో ఎక్కువగా యూజ్ చేస్తాం. And here the gradient fiber may observe the consideration of the ray diagram. Here the index profile will be considered as a n of r is equal to n1 into 1 minus 2 delta r by a whole square square root of 1 by 2. Here r will be less than a. R will be less than a. In that condition, it will be represents the expression. If r greater than or equal to a, then it represents the cladding n1. That means n2. That is equal to the n2. Okay. So here you can see the in the figure. The auxiliary ray, the some part of the signal which is the auxiliary ray, the mediastinal rays follows the sinusoidal trajectories of different path lengths. of different path lengths. So whenever using the gradient index fiber, then they will be form the some some sinusoidal trajectories of the different paths. Okay, whenever you are transmitting the different paths, they will be formed tangent shapes across the sinusoidal will be represented. Okay, and the velocities is inversely proportional to the local refractive index. Therefore, the long sinusoidal paths are compensated for higher speeds in the lower index. Okay, ఎప్పుడైతే మనకి group velocities అనేది perpendicularly proportional to the refractive index, then automatically the longer sinusoidal path is compensated uh, by high speeds in lower index. Respond. It's okay. So for the multimode fiber bandwidth is improved, you will go for the parabolic. Okay, so if you consider the difference in the faster and slowest modes in the gradient index fiber, then ray theory will be described this out is equal to doubt is to by 2c. Okay, L into equation for the time. Okay, gradient index fiber లో మన expression అనేది తీసుకుంటే ఆ విధంగా తీసుకుంటాం. However, here you can also be written as tau tz delta squared by 8c, delta squared by 8c. So whenever you consider the electromagnetic expression which is considered for the delay differences in the ray theory. Okay, and here from the two expressions is not same. So the RMS pulse broadening is usually parameter in multimode gradient index fiber. So we can see D is depending on the evaluation. Value kuda ee value anedi some parametric metrics. Okay. And so the RMS value of the gradient index multimode fiber. Okay. So more dispersion will be taken.
ఉన్నాయని చెప్పాడు ఒక సిగరెట్ ఇచ్చి మీద చూడండి మూడు తొమ్మిది కదా 27
Okay. We have another more dispersion which is its polarization state. So optical signal ఒక fundamental property, it is of a light state which long optical signal వచ్చేసరికి polarization అనేది తీసుకుంటాం. Here polarization వచ్చేసరికి ఏంటంటే electric field oriented state polarization of the light input must be maintained over significant distance. ఓకే, మనకి చాలా అప్లికేషన్స్ అనేది తీసుకుంటున్నాం. సో by reference modal by of the light అనేది మనం ఇక్కడ మెయిన్ of the orientation of the light signal in fiber the
సార్ వాయిస్ బ్రేక్ అవుతుంది సార్.
polarization polarized to propagate. Okay, the modes which will be having the different propagation when the fiber cross section is independent of the fiber length in z direction. Okay, fiber cross section of the fiber length in direction by difference for the fiber is modes ఏదైతే మనం degenerated modes తీసుకున్నాం x and y respectively. Okay, and lambda, we already know that lambda is the causing, so which will be considered as a pi of zero length L, and the phase connection to maintain the so the condition for bireference coherence be maintained over a length as a coherence length. So LC is equal to C by dou F. So which will be represented as delta square by B of dou lambda. So here dou F which represents the source frequency with C is also known as velocity of light in vacuum, and finally dou lambda which is considered as a source with phase coherence is maintained, then beta is equal to k into n1 into 1 minus 2 delta of 1 minus b whole power 1 by 2. Okay, phase coherence అనేది మెయింటైన్ చేస్తే మనం propagation constant beta is equal to k into 2 delta whole power by 2. Okay, so this condition leads to the polarization state, which is generally elliptical. Okay, elliptical, which moves periodically along the fiber. Okay, this is shown in the representation of the diagram here. Polarization condition states, and first one which will be represents the where the incident linear polarization is 45 degrees with respect to of x-axis, because circular polarization at pi value is equal to pi by 2. That is the second diagram which represents polarization, and linear polarization again at pi is equal to pi. Okay, that is the represents the linear polarization. The process continues through along the circular polarization at 3 pi by 2 before returning to the initial linear polarization, that is 2 pi. So the characteristics length which is represents the corresponding process is known as beat length. Okay, ఈ characteristics ఏదైతే మనకి linear polarization and circular polarization repeating the polarization states which is represents the elliptical shape. So this type of representation is called as beat length. Okay, the characteristics length corresponding to the process. Hello.
Hey.
ఇక్కడ బీట్ లెంత్ అనేది తీసుకుంటున్నాము, then it is represented as lambda by birefringence. So by putting the value of birefringence in the beat length, then finally we can obtain that LB is equal to L into 2 pi by beta x minus beta y into lambda. So lambda cancel అయిపోతే then beat length is equal to 2 pi by beta x minus beta y. So here the single mode fibers have beta lengths of the few centimeters. Single mode fibers which will be choose that the beta lengths will be few centimeters. So the position optical which is presented in the figure as shown in the above diagram. Okay, so here the signal energy at the given wavelength occupies two orthogonal polarizations. Slowest mode and fastest mode. If you go for the two orthogonal polarization modes will be taken for a wavelength occupies. Okay, varying the birefringence along its length. Okay, varying the birefringence along its length, it causes each polarization mode to travel slightly different velocities. Okay, one is faster velocity and another one is slower velocity. Then resultant polarization time will be delta tau polarized mode D, PMD suffix, that is equal to the difference between the two orthogonal polarization, that is faster mode and slower. So the difference which is represents the polarization mode dispersion. If the group velocities of the two orthogonal modes VGX and VGY, difference will be takes place between the time delay, then finally we can obtain the polarization mode dispersion time delay delta T suffix PMD is equal to L by VGX minus by VGX of the X component and group velocity of the Y component. L is the length of the fiber, how much it will be traveled. The light undergoes the polarized mode. Okay, here you can see clearly the delay was the same two orthogonal modes. ఎప్పుడైతే మనం two orthogonal modes అనేది optical fiber లో ట్రాన్స్మిట్ చేస్తున్నామో due to the group velocities obtained between the two orthogonal modes, then we can obtain the time delay. That time delay which is represents the polarized mode dispersion time delay. That is the representation of the polarized dispersion. Okay, and finally we can obtain the overall dispersion. Fiber dispersion. So if you go for the overall fiber dispersion, you must be add the both intermodal dispersion and intramodal dispersion here. Okay, coming to the polarized mode dispersion, not considering. Okay, and you can see that polarized dispersion mode for a multi-mode fibers sigma T total dispersion, sigma T, which is the total dispersion of the pulse broadening, then it is equal to square root of sigma intra square plus sigma inter square. We can substitute the values of the intermodal dispersion and intramodal dispersion here. Then we can obtain the total internal dispersion. So intramodal dispersion మనం ఇక్కడ consideration తీసుకుంటే we have some assumptions here. The intramodal dispersion includes the dispersion due to both waveguide dispersion and material dispersion. So that values will be also be taken into the count. So here waveguide dispersion is generally negligible. Material dispersion will be in multimode fibers is both will be equal to the sigma inter is equal to sigma material. So multimode fibers తీసుకుంటే కంపల్సరీగా మనకి మెటీరియల్ డిస్పర్షన్స్ అనేది ఈక్వల్ టు ద సిగ్మా ఇంటీరియర్, బికాస్ వీఆర్ అవాయిడింగ్ ద వేవ్గైడ్ డిస్పర్షన్. వేవ్గైడ్ డిస్పర్షన్ అనేది నెగ్లిజిబుల్ కాబట్టి మల్టీమోడ్ ఫైబర్స్ లో బోత్ విల్ బి ఈక్వల్. Coming to the intermodal dispersion, here also sigma inter is equal to sigma step index. Okay, sigma inter is equal to sigma multimode step index equal. So and sigma inter is equal to sigma graded index fiber will be also be taken into the count. Okay, that is the overall fiber dispersion for multimode fibers only. For multimode fibers only. Okay, into the we have so far we discussed the multimode fibers only. Multimode fibers, intramodal dispersion, multimode fibers, gradient index fiber. But we are coming to the overall dispersion in single mode fibers. We have another topic which is totally different from the multimode. Some equations will be used here. Single mode fibers is a diameter is very low. So here also dispersion losses will be very high. So the dispersion in single mode fibers occurs entirely from intermodal dispersion only. Okay, మనకి intermodal dispersion కాకుండా మొత్తం single mode fibers అనేది only it will be obtained in the intermodal dispersion. So the time delay or specific group delay which is used for the unit that will be given as tau z. Tau z is the time transit or group delay for a unit length. So that is equal to the 1 by c into d beta by dk. 1 by c into d beta by dk. So we already know c is the velocity of light in vacuum and beta is the propagation constant for a mode, and k is the propagation constant for a mode in vacuum. Okay, beta అనేది ఏమో ఫైబర్ లో propagation constant, క్యాపిటల్ k వచ్చేసరికి ఏంటంటే propagation constant in vacuum. Okay, both are different. So if you go for the first order mode differentiating the chromatic dispersion for single mode fibers, then we can obtain that. Then we can obtain the capital D is equal to D by D lambda. మనం ఫస్ట్ ఆర్డర్ డిస్పర్షన్ పారామీటర్స్ అనేది తీసుకుంటే మనకి సింగిల్ మోడ్ ఫైబర్స్ లో దట్ ఈస్ రిప్రజెంట్స్ ద D tau is equal to D tau z by D lambda. Okay, differentiate చేస్తున్నాం with respect of the lambda. So the total dispersion parameter when lambda variable replaced by the omega, lambda variable will be replaced by the omega, then we can obtain that dou t is equal to minus omega by lambda into D tau z by D omega, D tau z by D omega. Then finally we can obtain that minus omega by lambda into D square beta by D omega square, D square beta by D omega square. అంటే మన ఇక్కడ ఫార్ములా అనేది ఇక్కడ సబ్స్టిట్యూట్ చేస్తే డౌ జీ వాల్యూని సబ్స్టిట్యూట్ చేస్తే డి బీటా బై డి ఒమేగా రాయాలి డీకే అనేది. సో మనం ఆ వాల్యూని ఇక్కడ సబ్స్టిట్యూట్ చేసుకుంటే మనకి ఇక్కడ వస్తుంది. ఓకే, బీటా వాల్యూ ఆల్రెడీ క్యాలిక్యులేటెడ్ ఫర్ ఏ సింగిల్ మోడ్ ఫైబర్స్ ఇన్ ఇంట్రామోడల్ డిస్పర్షన్. సో వీ కెన్ కన్సిడర్ దట్ so beta is equal to k into n1 into 1 minus 2 delta into 1 minus b whole power 1 by 2. So delta is the refractive index and small b, which is represents the normalized propagation constant. Kapati beta value you can find the RMS pulse broadening of the intramodal dispersion of a length bar is given as that is equal to sigma lambda into L into d tau z by d lambda. So whenever it will be d tau z by lambda value will be substituted here. Then finally we can obtain the sigma L into 2 pi by c lambda to d beta by d k square. So sigma lambda అనేది source ఒక RMS spectrum length width. Okay, sigma lambda అనేది source ఒక RMS spectrum length. The dependency of pulse broadening of fiber properties the interrelated effects in complicated అంటే పల్స్ బ్రాడనింగ్ ఒక ఫైబర్ మెటీరియల్స్ ఒక ప్రాపర్టీస్ తీసుకుంటే అనేది మేజర్లీ 3 ఎఫెక్ట్స్ అనేది మనకి ఇందులో చూడార్. వన్ ఈస్ మెటీరియల్ డిస్పర్షన్ పారామీటర్ that is d material is equal n by d lambda square. So n1 n2 మనకు తెలిసిన కోర్ క్లాడింగ్ ఒక so that is equal to n1 minus n2 by lambda c into అలానే మనకి థర్డ్ interrelated effect వచ్చేసరికి profile dispersion parameter sorry d delta by d lambda. So it is represents the by d sorry d p is equal to d delta by d lambda. total dispersion లో మనం ప్రొఫైల్ డిస్పర్షన్ పారామీటర్ అనేది నెగ్లెక్ట్ చేయొచ్చు, అంటే పోలరైజ్డ్ అనేది నెగ్లెక్ట్ చేయొచ్చు. ఫర్ if you go for the total dispersion tt is equal to dm plus dw plus dp for a single mode fibers. So if you see the how much of wavelength and dispersion will be takes place, the wavelength, much of wavelength the dispersion will be takes place, how it will be behaves. Wait a minute. Okay, here you can see dispersion how it will be shifted. Okay, for a longer wavelengths the material dispersion is very high. So for single mode standard dispersion will be obtained across 1300 nanometers. Okay, for a dispersion platter, the dispersion platters will also be shifted to the down, which is considered as a dispersion flathead. Okay, the lower dispersion. Are non-dispersion shifted fibers. Okay, non-dispersion shifted fibers ఉన్నాయి. ఫైబర్స్ కి మనం డిస్పర్షన్ అనేది కనుక్కోవాలంటే dispersion shifted fibers across the 1270 to 1340 dispersion range. Okay, so for that will be consider the some standard recommended fitting group velocities for unit length. We can consider the semi-Miller equation that will be taken as a tau is equal to a plus b into lambda square plus c into lambda power minus 2. ఒక ఈక్వేషన్ అనేది తీసుకున్నాం ఇక్కడ ఫర్ క్యాలిక్యులేషన్ ఆఫ్ ది నాన్ డిస్పర్షిఫ్టెడ్ fibers. Okay, here a b c are the curve fitting parameters. Then the expression which is represented as tau is equal to tau naught plus s naught by 8 into lambda minus lambda square by lambda whole square. The direct equation summa, there is a need not necessary for explanation. Okay, directly equation will be obtained by using the curve fitting parameters. Here the equivalent expression will be taken, where tau z is related to the time delay minimum at zero dispersion, and lambda naught is wavelength, and s naught which is represents the value of dispersion slope. So it is represented as d capital D by t lambda. Okay, that is the representation. And if you go for the dt of lambda is equal to d tau by d lambda. So hence the dispersion represents capital suffix d in of lambda is equal to lambda into s naught by 4 into 1 minus lambda naught by lambda whole power 4. That is the dispersion for non-dispersion shifted fibers. So if you calculate dispersion shifted fibers across the range of 1500 to 1600 nanometers. In equation shift వచ్చేసరికి shifted dispersion is equal to tau naught plus s naught by 2 into lambda minus lambda naught whole square. So this you can find out this expression dt of lambda is equal to s naught, that is the expression 15 to 0.0508 dispersion df ఈ వేవ్ ఫామ్ ఒకటి వస్తే సరిపోతుంది. ఇదేంటంటే మొత్తం మోడ్ trajectories అనేది inside the optical fiber. The master, some of the modes will be having the lower, so that is the represented across here. So various trajectories అనేది ఓకే, మనకి ఫైనల్ గా ఏంటంటే సిగ్మా గ్రేడియంట్ ఇండెక్స్ ఇజ్ ఈక్వల్ టు డిస్పర్షన్ ఇజ్ ఈక్వల్ టు డెల్ బై డి సిగ్మా ఎస్ అనేది తీసుకుంటున్నాం. ఓకే, సో థియరిటికల్ గా మనకు ఫార్ములా వచ్చేసరికి ఏంటంటే బెస్ట్ థియరిటికల్ ఇంటర్మోడల్ డిస్పర్షన్ ఆర్ఎంఎస్ పల్స్ బ్రాడనింగ్ వాల్యూ ఇస్ L into N1 delta square by 20 square root 3 into C. That is the best formula for the intermodal dispersion for gradient index fibers. Okay, so we have another representation, pulse broadening. Sorry, pulse broadening in the polarized modes అనేది dispersion అనేది ఎలా తీసుకుంటున్నామంటే ఇక్కడ కంపల్సరీగా ఫండమెంటల్ ప్రాపర్టీ ఆఫ్ ది ఆప్టికల్ సిగ్నల్ వచ్చేసరికి పోలరైజ్డ్ లైట్ అనేది హౌ ఇట్ విల్ బి ప్రాపగేటెడ్ ఇన్ ద ఫైబర్. సో పోలరైజ్డ్ లైట్ అనేది ఎలా మనకి కన్సిడరేషన్ తీసుకుంటున్నాం, దేని మీద డిపెండ్ అవుతుందంటే మోడ్ బై రిఫరెన్స్ అనేది విచ్ విల్ బి టెల్స్ అబౌట్ ది పోలరైజేషన్ ఆఫ్ ది లైట్ into the optical fiber for a length L. Okay, based on that birefringence we can explain the polarized mode. So birefringence is equal to, they will be obtain the some beta x minus beta y by 2 pi by lambda. So మన birefringence value అనేది మనకు తెలుసు. So we want to identify the with some length, we want to identify the length. So based on the length you can find out the some formula and you will be substitute the length value in the length by reference value, then we can obtain the finally we can obtain the beat length LB is equal to, okay, LB is equal to which will be represents the beat length. So if you go for the birefringence, based on the birefringence we'll go for the polarized mode dispersion. If we have two orthogonal polarizations will be taken in the x direction and y direction, which will be one is faster mode and second one is slower mode due to the different group velocities of that particular two orthogonal modes. ఏదైతే మనం two orthogonal mode అనేది తీసుకుంటున్నామో ఆ two orthogonal mode which will be having the different group velocities. Based on that they will be they will be travel some length L, then they will be obtain the polarized mode dispersion in time delay, that is represented as tau t. Polarized mode dispersion is equal to L by Vg x minus L by Vg y. That is the polarized mode. If you go for the total internal total overall fiber dispersion, which is represented as sigma t is equal to of sigma in square plus square. So values ni ఏవైతే ఇప్పుడు దాకా వాల్యూస్ ఉంటాయో ఆ వాల్యూస్ ని ఇక్కడ సబ్స్టిట్యూట్ చేస్తే we can obtain the total dispersion for multimode fibers. If you go for the single mode fibers, then we can obtain the some different representation of the single mode fibers. Okay, further ఏం రాయాలంటే ఇక్కడ మొత్తం రాయొచ్చు. ఓకే, ఇది ఎక్కడ దాకా dispersion T is equal to Tm plus Tw plus Tp. ఓకే, T అనేది మెటీరియల్ డిస్పర్షన్, వేవ్ గైడ్ డిస్పర్షన్, Tp అనేది ప్రొఫైల్ డిస్పర్షన్ పారామీటర్ అనేది. ఈ మూడు ఎక్కడ చెప్తున్నామంటే ఇట్ విల్ బి ఎక్స్ప్లెయిన్ డ్యూ టు హలో అందరికి అర్థమైంది. ఈరోజు క్లాసు కొంచెం డిఫరెంట్ గా ఉంటుంది. ఇది సింగిల్ మోడ్ ఒకటి, మిగతా అంతా ఆర్డర్ లో ఉండిద్ది, కొంచెం అర్థమయ్యేటట్టు. ఓకేనా, ఇంకొకటి ఉందమ్మా, అది కొంచెం పెద్దది, పల్స్ బ్రాడనింగ్ అని. ఏదైతే ఇక్కడ మీరు డెరివేషన్ ఇక్కడ కనుక్కున్నారు చూడండి, ఓవరాల్ డిస్పర్షన్ లో ఈ డిస్పర్షన్ ఫార్ములాని యూజ్ చేసుకొని ఇంట్రా మోడల్ ని మనం ఇక్కడ సబ్స్టిట్యూట్ చేసుకొని చేస్తాం. ఎలా వస్తున్నాయి అని ఈక్వేషన్స్ అనేది కొంచెం పెద్దది, రేపు చెప్తాను అది. ఓకేనా, ఈరోజు కుదిరితే ఈ రోజు కానీ రేపు కానీ ఫీడ్బ్యాక్ పంపిస్తాను లాస్ట్ వీక్ ది, అందరూ ఫిల్ చేయండి. ఓకేనా, హలో వినపడుతుంది అందరికి? పల్స్ బ్రాడనింగ్ అని ఒక టాపిక్ ఉంది, అది కొంచెం లెంతీ 3 pages 4 pages ఉంది డెరివేషన్, రేపు చెప్తాను అది. ఓకేనా, దీంతో సెకండ్ యూనిట్ అయిపోయింది. ఒక పల్స్ బ్రాడనింగ్ ఒక టాపిక్ ఒకటే మిగిలింది. కొంచెం lengthy అది. How you can identify the pulse broadening of the intermodal dispersion and intramodal dispersion. Okay. Hello. Hello.